So the next group of problems in this section ask me to factor out a -1 from the polynomial. And what all the problems on this page have in common is that the very first term is negative. And it's common when we're in a chapter on factoring and we're asked to factor, it's common to ask you to factor out a -1 to make the first term inside the parentheses positive. So what I'm going to do in problem 18 is I'm going to factor out a -1, like the instructions told me. And when I factor out a negative, I just flip the signs. The -3x is going to turn to positive 3x, and the positive 5 is going to turn to -5. I claim that this is considered factoring out a -1, and that 1 is really not necessarily to write. If you just wrote a negative sign in front of a parentheses, that's equivalent to factoring out a -1 because the negative is there and the 1's implied. I'm going to check to show you that I factored out the -1 correctly. Anytime I write a factoring answer, I should be able to clear the parentheses, in this case by distributing. I'm going to go -1 times 3x and -1 times -5. -1 times 3x, I multiply the -1 and the 3 and get -3. I leave the x. I multiply -1 times -5 and get a +5. I look at these and they match perfectly, so I know I factored properly. So factoring out a -1, super easy skill, turns out to be an important skill because it's customary if you're factoring and the first term is negative to factor out a -1, or more complex, a negative with the common factor. But getting used to factoring out negatives or equivalently -1s are important. So that's why I wrote these problems. So in problem 20, the instructions are to factor out a -1, which is equivalent to just factoring out a negative. You can do the 1 or not show the 1. That's still factoring out a -1. And to factor out a -1, I just flip the signs. Any negative sign turns positive. Any positive sign turns negative. So both of these would be considered acceptable answers for number 20. Either -1 times x plus 4. I change both the -x and -4 to positive. In problem 22, if I was going to factor out a -1, I'd write either a -1 in front of a parentheses or just the negative sign in front of a parentheses, and I'd flip the sign. The -7w I'd make positive 7w, the positive 16 I'd make -16. And then I wouldn't show both, but whatever you prefer. I like the 1 with the negative. It makes it easier if I'm doing algebra to clear the parentheses than just the negative. 24, if I'm factoring out a -1, the -2x will turn to positive 2x in the parentheses. The -3y will turn to positive 3y. The positive 9 will turn to -9. And similarly, you don't have to have the 1. And the last one in this grouping, for the 26, if I factor out a -1, I'd be left with 13y minus 4z plus 11r. And again, I could have the negative up front without the 1, and that would be okay. So this is an important skill, but not the end of what we need to do with factoring with negatives. And that's what the next group of problems are. 27 through 38, the instructions tell me to factor out the opposite of the GCF. I know what the GCF is. It's the biggest number that divides into all the numbers and the smallest exponent if all the problems have the same letters. The instruction here tell me to factor out the opposite of the GCF. That's the GCF made negative. So that's what I'm going to do for each one of these problems. I'm going to identify the GCF, and I'm going to put a negative in front to find the opposite of the GCF, and I'm going to shove that in front of a parentheses. So in problem, I'm not going to worry about the signs, I'm just going to worry about the numbers. In problem 28, I'm going to look for the factors of 20, and the factors of 20 are 1, 2, 4, 5, and 20. So for 20, the factors are 1, 2, 4, 5, and 20. And if you can get the common factor bar without looking at this sheet, it's better. The factors of 15 are 1, 3, 5, and 15. The common factor, the greatest common factor of the numbers are 5. So I'm going to factor out the greatest common factor, and I'm going to find the opposite of it, and I'm going to make it negative. So I'm going to factor out a negative, which is going to be the opposite of the GCF. The GCF would have a 5 for the number, and both terms have a y, and the smaller exponent is y to the first. When I factor out the opposite and the GCF, I need to change the signs. So immediately, this negative is going to turn to positive. When I fill up the parentheses, factoring out a negative causes negative signs to change to positive. The 20, I'm going to divide by 5 and get 4. And I have 2 y's up front. I took 1 y away. I'm going to be left with 1 y. Move on to the second term. I factored out a negative, so the negative sign is going to flip. Always when I factor out a negative, signs flip. That's like factoring out a -1, just more complicated. The 15, I'm going to divide by 5, and 15 divided by 5 is 3. And I had a y, I took it away. I claim that this is the answer to problem 28, but I should check because it's the first in a group, and I don't check that often when I'm factoring greatest common factors because it's pretty easy. It's not that students don't make a lot of mistakes. But the checking part of this, if I wanted to clear the parentheses, I do -5y times 4y and -5y times 3. The first multiplication, I do -5 times 4, which is -20. I add the exponents of 1 and 1 on the y and get a y squared. Second multiplication, I do -5 times 3 and get -15, and I leave the y. I compare this to the original problem. Because it's exactly the original problem, my answer is correct. 30 is tricky. I know I'm going to factor out a negative, but when I'm finding the common factor part of it, I'm not going to worry about the negative. I'm just going to worry about the factors of the numbers, and this is a tricky one. So the factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. So 1, 2, 3, 6, 7. You don't have to write all these down. Just some students don't do numbers well, and this is just to help the students that can't just look at it and know what the common factor is. But a lot of students could just look at this and go, oh, the common factor is what it is. The factors of 24 are 1, 2, 3, 4, 6. Forgot the 8. 1, 2, 3, 4, 6, 8, 12, and 24. So 1, 2, 3, 4, 6, 8, 12, and 24. And 4 is so baby, I don't need to go to my sheet. It's 1, 2, and 4. I look at this, and it's tempting to say 4 is the greatest common factor, but that 42 doesn't have a 4. 6 isn't the common factor because 4 doesn't have a 6. The greatest common factor is just going to be the 2 that they have in common. When I go to write my answer, because the first term is negative, I'll find the opposite of the GCF, which is the GCF with a negative in front. The number's going to be 2, and then I look at the exponents. I see they all have an a to the 5th, a cubed, and a to the 1st. I need an a to the 1st. Start my parentheses. Factored out a negative, so the negative sign is going to turn positive. And then I'm going to divide 42 divided by 2. So I flip the negative sign to positive. 42 divided by 2 is 21. The first term had 5 a's. I took out 1. I'm going to be left with 4 a's. Moving across to the positive 24, because I factored out a negative, I'm going to flip the positive sign to negative. Because I factored out a 2, I'm going to divide 24 divided by 2, and 24 divided by 2 is 12. And then that term had 3 a's. I took 1 a away, so I'm left with 2 a's. Running short on room. The last term, I factored out a negative, so the negative sign is going to turn to positive. I factored out a 2, so I'll do 4 divided by 2 and get a 2. That term had an a, and I factored it out. So I claim the answer to problem 30, in front of the parentheses, the opposite of the GCF is -2a, and inside the parentheses, I get 21a to the 4th minus 12a squared plus 2. 32 is written in a bad order. 31 is written in a bad order. I'm just going to leave that bad order. I don't know when it would be preferable to have something written in a bad order, but this is written in a bad order. So I'm going to find the GCF real quickly. I'll look at the factors of 5. It's a prime number. They're just 1 and 5. I look at the factors of 10, and it's a small set of factors, 1, 2, 5, and 10. And most students, again, they don't need to write down the factors. They can figure them out in their head. But the common factor for the number is going to be 5. I'm going to factor out the opposite of the common factor because the first term is negative. Both terms have a y, so I'm going to factor out a y to the first power because that's the smaller of the exponents. Inside my parentheses, because I factored out a negative, that negative sign is going to turn to positive. I'm going to divide that 5 by 5 and get a 1. And I had a y and I took it away. So first in my parentheses, I'm going to get a 1. After this plus sign is going to turn to minus. I factored out a 5, so I'm going to take that 10 and divide it by 5 and get 2. I had 2 y's to the right of the equal of the 10 squared, of the y squared. I take out one of them and I'll get y. This is a completely good answer. If you took the time to rewrite this, if you said, oh, I don't like that that's written in an improper order, if you wrote it like this, 10y squared minus 5y, then your factoring, you wouldn't factor out a negative. You wouldn't factor out the opposite of the GCF. I generally only factor out the GCF with a negative or the opposite of the GCF if the first term is negative. If I rewrote the problem like this, the common factor would be the positive 5y without the negative. And then I would divide the numbers by 5 and take a y away. This is equivalently a good answer. They don't look a lot like each other, but if you multiplied out both of these, you'd get both a 10y squared and a minus 5y. They're both equivalently right. If I move down to 34, if I look at the factors of 2, the factors of 2 are just 1 and 2. These equal signs seem silly. Their colons almost seem more appropriate. If I look at the factors of 4, the factors of 4 are 1, 2, and 4. So the number part I want to factor out is 2. The first term is negative, so I'll find the opposite of the GCF, which is going to have a negative in front of the GCF. Both terms have an a. First has an a squared, the second has an a to the first. I'll take the smaller a to the first. Both have a b, and the smaller exponent on the b is a b squared. So my common factor is going to be a negative 2ab squared. Because I factored out a negative, I'm going to change that negative sign to positive. Because I factored out a 2, I'll divide that 2 by 2 and get a 1 that I don't need to write. I have an a squared. I factored out one of the a's, so I'm left with an a. I had a b squared. I factored them both out, so I don't need to write a b. Moving across, because I factored out a negative, that negative sign is going to turn to positive. Because I factored out a 2, I'll divide that 4 by 2 and get positive 2. I took the a away. I took 2 of the 3 b's away, and I'm left with 1 b. I'll show you that this checks, not that it's necessary, but all of these problems can be checked. If I wanted to check this, it's optional, but never a bad idea to check. To check this, I'd go minus 2ab squared times a and minus 2ab squared times 2b. The first multiplication, I'm just going to multiply the a's by adding the exponents and writing it in a nice order. I'm going to add the exponent of 1 and 1 and get 2. The second multiplication, I'll multiply the negative 2 and positive 2 and get negative 4. I'll leave the a alone but add the exponents of 2 and 1 on the b and get a b cubed. If I look at these two, they match perfectly, so I know my answer is correct. You can check every time, but I don't have a tendency to check so much when I'm doing the GCF factoring just because I'm pretty confident in my work. For 36, I'll look at the numbers 15. The factors of 15 are 1, 3, 5, and 15. I have the sheet in front of me. The factors of 12 are 1, 2, 3, 4, 6, and 12. You can see them here if you need. And the factors of 15 are there. And the factors of 9 are 1, 3, and 9. The biggest common factor is 3. So when I do my common factoring, since the first term is negative, I'm going to factor out the opposite of the GCF. The GCF starts with 3. And now I look for the letters. There's an x squared, and an x to the first. I'll take the x to the first. I see all have a y to the first, a y cubed, a y to the first. I'll take my y to the first. They all have a z to the first, a z cubed, and a z to the first. I'll take the smallest exponent of z to the first. Now I flip the signs, divide by 3, take 1x, 1y, and 1z away. So first term, flip the negative sign to positive, done with that. Now I'll divide 15 divided by 3 and get 5. It had 2 x's, I took 1x away, I'm left with 1x. I took the y and the z away. I factored out a negative, so I'm going to flip the positive sign to negative. I factored out a 3, so I'm going to do 12 divided by 3 and get 4. It had 2 x's, I took 1x away, I'm left with 1x. It had 3 y's, I took 2 y's out, I'm left with 2 y's. It had 3 z's, I took 1 z away, I'm left with 2 z's. Next, lastly, I factored out a negative, so I'm going to flip that negative sign to plus. I factored out a 3, I'll do 9 divided by 3 and get 3, and I took the x, the y, and the z away. So for problem 36, claim that's the answer. Lastly, I'm just going to pick out the common factor in my head. No, I won't. If I look at the 8, the factors of 8 are 1, 2, 4, and 8. The factors of 6 are 1, 2, 3, and 6. The factors of 10 are 1, 2, 5, and 10. So my greatest common factor numerically is going to be a 2. Because the first term is negative, I'll find the opposite of the GCF. So I'll shove a negative in front of the GCF. And now I look at each term has an r. I take the smallest exponent of r to the first. Each term has an s. I take the smallest exponent of s to the first. Each term has a t. I'll take the smallest exponent of t to the first. Then I'm going to fill up my parentheses. I'm going to change the signs because I factored out a negative. So that negative is going to flip to positive. That 8 I'm going to divide by 2, and 8 divided by 2 is going to be 4. I had 3 r's. I took 1 away. I'm left with 2 r's. I took the s away. There were 2 s's. I took 1 away, so I'm left with 1. The minus sign's going to flip because I factored out a negative, so I have to flip the sign. That 6 I'm going to divide by the 2 that I factored out. I'll be left with a 3. I had 3 r's. I took 1 of them away. I'll be left with 2 r's. I had 2 s's. I took 1 of them away. I'll be left with 1 s, and I took the t away. This negative sign is going to flip to positive because I factored out a negative. The 10 I'm going to divide by 2 and get 5. And I took each of the 1 r, s, and t away. Inside the parentheses, I don't know if my terms are written in a good order. I guess they're good enough. In this problem, this wasn't a good order inside the parentheses because this middle term is a 5th degree term. Maybe it should be written first. But since the original problem was written in a bad order, I'll live with the bad order. The next group of problems are easy. They're weird at first, and they're kind of funky to check. So I'm not going to show the checking because it's more confusing than catching on to what's going on. But they're the bridge between section 1.1 and section 1.2. So they're important, but it's a weird common factor. Each of the problems between 39 and 52, there's a common parentheses. And when you have a common parentheses, that common parentheses is the greatest common factor. So when I look at problem 40, what we have in common is the parentheses of x minus 5. That entire parentheses is going to be considered my common factor. When on either side of either a plus sign or a minus sign, you have a common parentheses. That common parentheses is going to be the common factor that I'm going to write first. And then I'm going to create the parentheses, the one parentheses that I normally create when I common factor, and whatever to the left of the parentheses is going to go inside. So what's to the left of the first x minus 5 is the x. It's going to go inside that parentheses that I'm filling up. And what's to the left of the second x minus 5 is going to be a plus 2. that's going to go inside the second parentheses. That's the answer. These are kind of funky to check. They're more complicated to check than it's worth. When we need this skill in section 1.2, I'll show you how to check when it's more appropriate to check. But this is just kind of a bridge between the sections, and it's not good to check. I've tried to do it before, and it's been way more harm than good. So I'll just teach you this skill, which is weird at first to have a common factor that has a subtraction or addition in it. That's odd. In problem 42, the common factor is the common parentheses of x minus 4. And then I'm going to make a parentheses and fill it up with what's to the left of each of the parentheses. What's to the left of the first x minus 4 is x squared. What's to the left of the second x minus 4 is negative 5. Claim that's considered factored when you have a common parentheses. Problem 44, there's a common parentheses of z plus 7. I'm going to write that common parentheses first. Then I'm going to create a parentheses to fill up. I'm going to fill it up with the 6y and the minus 5 that are in front of the parentheses that have the z plus 7s inside. That's considered completely factored. For problem 46, the common parentheses is 5x plus 1. I'm going to write that common parentheses first. After writing one of the common parentheses, I'm going to create a parentheses, and inside of it, I'm going to write what's to the left of each of the 5x plus 1 parentheses. The first 5x plus 1 parentheses has an x in front. The second has a minus 4 in front. Consider that completely factored. This is a really important skill for section 1.2, moderately important in 1.3, really important again in section 1.4. Just a few more problems to push through. Problem 48, there's a common factor of the parentheses 6x minus 1. I'm going to write one copy of that 6x minus 1, and then what's in front of the 6x minus 1s are going to go in the second parentheses, in this case, a 5x and a plus 6. For problem 50, the common parentheses is 2x minus 3y. What's in front of the first 2x minus 3y parentheses is going to lead off my second parentheses, which is a 7x squared. And what's in front of my second is going to finish up that parentheses. Again, it's really funky to check these, and it's not, I'd like to, but it's been a disaster, so I'm punting on the checking. But it's not important now, the checking. It's going to be important in the next section. So for this problem, I write the common parentheses of y plus 4, and then what's in front of the common parentheses of 7y minus 2. All right, so that's the entire section. This is an important skill. It's a skill that will flow through the entire chapter as we learn new factoring techniques for different styles of problems. So I'll stop the video. Make sure you have this section perfected before you move on.